Hello everyone, welcome to a new video from Quantum Singularity. In this video we will cover the recent news regarding IonQ and its first quantum computing system delivery to Europe. Basically it's a historic moment for IonQ as they have successfully delivered their first overseas ion trap to Basel in Switzerland. This marks a significant step in developing a quantum innovation hub for the European region. Pictured are IonQ's Thomas Kramer and Noam Zakai and QuantumBasel's Damir Bogdan and Thomas Stahelin. We can see they're all standing around the ion trap which was delivered yesterday. IonQ's cutting-edge ion trap technology is officially on European soil. This milestone highlights IonQ's commitment to advancing quantum computing capabilities globally. The new Quantum Computer Innovation Hub in Switzerland will serve as a center for research, development and deployment of quantum technologies. This hub is poised to accelerate breakthroughs in various industries across Europe. With this ion trap, basically IonQ aims to bolster collaboration with European researchers and institutions, fostering an environment of innovation and discovery. We can expect groundbreaking advancements in quantum algorithms, hardware and applications, which is great for further applying quantum systems to customers and to solving problems. If we focus a bit more like where it's been delivered, so as we said, Basel in Switzerland, and Switzerland is known for its strong emphasis on scientific research and technological advancement. It's the perfect location for this hub, as the synergy between IonQ and the Swiss institutions will drive the quantum frontier forward. This development and delivery aligns with IonQ's broader strategy, which has been often mentioned that the main strategy is to make quantum computing accessible and impactful worldwide. By establishing a presence in Europe, they ensure that the region remains at the forefront of this technological revolution. As in the next few years, we should expect more and more development in these regions, as for example, Switzerland has many industries related to pharmaceutical and chemical companies, which is basically the long-hanging fruit for quantum applications. Quantum computers can help with molecular simulations, as they are very mathematical powerful. And as we can see on this image, there's an object that is being held. It's the actual ion trap from IonQ, which can be considered as the heart of the quantum computer, like the CPU of the quantum computer. Here we can see more in detail this ion trap. It contains the tiny charged particles called ions, which would be there in the middle of this like bow tie shaped device. These ions are the computer's qubits, basically like the bits in a regular computer, but much more powerful for specific compute-intensive tasks, right? So like quantum machine learning, or as we mentioned previously, for molecular simulations in pharmaceutical or chemical industries. The working principle is that ion traps use electric and magnetic fields to keep the ions in one place, so they are all like held in one place. Before the ions can be used for computing, they need to be in a particular calm state. This is achieved by cooling them down with lasers. So once we have the ions prepared, lasers are used to talk to the ions. So first of all, as we mentioned, the lasers will cool them down to a specific calm state, and once they are ready, then the lasers will again communicate with these specific ions. In the case of the quantum computer delivered to Basel in Switzerland, it was a 35Q AQ algorithmic cubic quantum computer. So we could imagine there was 35 useful ions. As there was within the device, there's more ions than this 35 because due to error correction algorithms and problems within quantum computing systems, then we need an extra number of ions. Then the laser beams, they will change the ion states, allowing IonQ's quantum computers to perform calculations. Basically, the lasers give the instructions to the ions using light with the laser beams. And these ion traps, they make use of the entanglement principle in quantum physics, which means that the qubits, in this case they are ions, as this is IonQ's quantum technology for implementing quantum computers using ions. There are other quantum computers, for example from Google or IBM, they use superconducting, or other startups and companies that are focusing on different technologies as neutral atoms. But in this case, IonQ is using ion traps, and these qubits, they will become interconnected and can instantly affect each other no matter how far they are. So it doesn't matter how far apart these ions are from each other, thanks to this entanglement quantum system or quantum physics principle, they will all immediately influence each other. And this ion trap, which is the device we can see on the screen, it helps create and manage these connections, which are crucial for the power of quantum computing. So, as mentioned, in this bow-sized device, in the middle we'll have the chain of ions, and then with all this whole system, as we can see on the image, it has all the connections for the specific lasers and cooling systems. And then after the computation is done, the ion trap helps IonQ determine the results. So again, the lasers, they will shine some beams on the ions again. So basically IonQ can see how they respond and determine to the outcome of the quantum calculations. So the whole quantum computer system from IonQ includes not only the ion trap, which is the heart of the system, but also the auxiliary systems as lasers, vacuum systems, cooling and isolation. This image depicts IonQ's 4th enterprise quantum computer, which is the same one as delivered to Switzerland. As we can see in the image, the quantum computer has a rather large size, once all auxiliary systems plus the ion trap have been installed. And as already mentioned by IonQ, the goal is to further reduce the size of these systems so they can be rack mounted in data centers. So this is everything for today, and this is very great news for IonQ as they are expanding, and especially with this major milestone as is the first delivery of a quantum computer overseas. Looking forward the next months and years to see what research and breakthroughs are performed by QuantumBasel in Switzerland, and hopefully with the good feedback other institutions will actually line up for purchasing the systems. So thank you very much for listening, and please stay tuned for the following videos.